Okay, so Primms is going to do what Kruskals does. Primms is going to find a minimum spanning tree, but in a different way. Okay, so reminder, what is a tree? I'll write it up.
Yeah.
Do you remember what a tree is?
A tree is where you put all the vertices down, and
Not necessarily all of them.
well, a tree is just two, with connected pathways with no cycles.
Connected graph.
Connected
Good.
graph.
Connected graph. No cycles. So let's look at this cycle split. What's a cycle?
A cycle is where the first where the end.
So it's an
pathway
example. It's a
equals
path.
the-
Yeah.
yeah.
It's a type of path. What type of path?
A type of path where the first path will equal the last path.
The end vertex of the final edge equals the start vertex of the first edge.
Yeah, and it's
Of the path. Yeah.
Yeah.
So what's the one word that we use for when that happens? When you end up back where you started?
Closed.
Closed. Excellent. Closed path. And then closed means that the end vertex of the final edge in the path equals the start vertex
Yes.
of the first edge
Yes.
in the path. Yeah? What about a path?
Oh, this is a really long one.
Yeah, really long.
Where you have a finite amount of edges.
Finite sequence of edges. It's important that it's a sequence.
Okay, a finite sequence
Not
of
just like a
edges.
collection of edges.
Okay, finite sequence of edges where the start of the next edge, no, where an edge starts from the end of a previous.
Yeah. So the
vertex.
end vertex of any edge in the sequence, the end vertex of one edge is the start vertex of the next edge in the sequence of edges. And then the really important thing about a path? Do you remember we couldn't go?
Oh yes, they can't repeat the vertex.
Yeah, no vertex
It's
appears more than once in the sequence. Sorry for my bad writing there. Yeah, right, connected. Connected graph?
Connected is where a path runs between the vertex.
Yep, there is a path. So if two vertices are connected, there's a path between them. If a graph is connected, there is a path between every pair of vertices. Yep, connected graph, no cycles, tree.
I think I'd have to rewrite that lots of times
100
to
times,
get that.
yeah. Spanning tree.
Spanning tree is where
is
you
a tree.
have you have every vertex.
That's it. Spanning means all vertices
Connected.
Well, all vertices are in the tree.
Yep.
Tree is connected graph, no cycles, so you're kind of embedding the definition of tree. Once you've said tree, you've got a connected graph with no cycles.
Okay.
So the only bit that we need to add on is that all vertices of the original graph are included.
Yes.
In the tree. Okay? Minimum spanning tree.
That's where the same again.
Yeah, it's a spanning tree.
Yeah, spanning tree again, but you're just looking for the minimum weight, which is like distance between the paths.
Yeah, it's minimum total weight.
Yes.
So the weight of the whole tree is as small as of the spanning tree is as small as possible. Good. So Primms. What we're going to do with Primms is we're going to start wherever you want. Okay. So and it's all going to be about nodes. It's not about edges anymore. It's about nodes.
Okay.
So pick your favourite node.
E.
Okay. So what we're going to do is we're now going to bring a new node into an existing tree. You know how Kruskals was like no, and then maybe this happened, and then that happened, and then that happened, and then finally they all joined up. Yeah.
Mm-hmm.
So you had trees kind of cropping up all over the place, and then they came together. With Primms, that doesn't happen. You have an existing tree, and then you add to the existing tree in the cheapest way possible. You bring a new town into the tree. So at the moment, your tree is just E.
Yeah.
That's it. And you're going to bring in,
here?
yeah, you can draw it there.
Okay.
You are going to bring in a new town into your existing tree, so you have to connect to E, but in the cheapest way possible. So which town are you going to bring in?
Right, so F is the cheapest connection.
Good.
And should I draw that?
Yes, you can
with
draw
the
that
lemon?
on. Yeah.
Should I say that?
Well, the important thing is that what we need to record is the order in which we built the tree. And if we don't do that anywhere, so you can just kind of do it here, EF11. That's what went in first.
Right.
Okay? And that's really important. That list records the order in which we built the tree.
Okay.
Okay, now this is an existing tree. This
Yeah.
is a tree. It's not yet a spanning tree, but it is a tree. We're going to add to this tree in the cheapest way possible. So bring in a new node.
So I want to bring in D then.
Okay, D.
And the cheapest way would be from, do I have to do it from E or F, yeah?
You can just, whatever's cheaper.
So if I do it from the E, it's 12.
Yeah.
So I'll bring in D.
Yeah.
Okay.
So bring D in. Yeah. You couldn't join, like, you might look at the CD and go, I want to join them.
That's what I was
but that's not bringing it into your existing tree.
Okay.
So D has now been brought in at a cost of 12. Now you've got this existing tree.
Yeah.
You're going to bring in a new node into this existing tree.
So I'll bring in A.
Okay. Yeah, that's the cheapest.
And AD then is 8.
Perfect.
And then I need to bring in C, and it doesn't matter if I go by A or D, so I'll go from D. Right?
Yep.
So
And can
D,
you see
C.
that because every time we do this, we're bringing in something from outside the tree into the tree,
Yeah.
we cannot create a cycle.
Yeah.
It's not possible to create a cycle because a cycle would be where we're adding an edge from a node to a node where there is already a path.
Yeah.
And we're joining that path up and making a closed path. But we're not really adding edges, we are, but we're adding a new node which so far isn't connected, so it can't make a cycle, it just can't.
So next I'll add B, and that'll be the final one, and obviously I'll pick the 8.
Yep.
So I got BC, and that's 8. And
Perfect.
it's all connected.
That's done.
Wow.
That's your minimum spanning tree.
It's much better than
Criscal.
Criscal, yeah.
Yeah, I think it is much better than Criscal. Plus it can be applied to a matrix, which we'll see in the next video.
Yeah.
So these are, again, examples to show that, because you chose E, didn't you, as your favourite start place?
Yeah.
But you could have started anywhere. That's one of the advantages of Primms, is that you can start anywhere. Yeah, you get different trees, but they've all got the same total weight, so they're all minimum spanning trees.
Okay.
This is a fun one. Now this is an example, it is a bit messy, but it's to show you that actually when it gets quite complicated, it's hard to see what the cheapest one to bring in is. The other thing that happens when you're doing Primms is you tend to get sort of focused on one part of the graph. So you might start here, bring this in quite cheaply, then this actually comes in here quite cheaply, this comes in here quite cheaply, that one comes in, and you forget all about this guy down here. And actually, this one was 10, and there's a connection down here which was 8. But we stopped looking over down the bottom because we got so obsessed with everything over here, and you're pulling into where you just were a minute ago, rather than pulling into your whole tree. So at every stage you're kind of taking a step back, looking at your whole existing tree, and pulling a new node in, one of these ones that isn't yet connected, in the cheapest way possible.
Okay.
And that's got nothing to do with what you did a minute ago. It's just, right now, look at my tree, what can I bring into that tree? What's the cheapest? So it does get a bit tricky, it's not easy, but same basic principle. So maybe with this one, it'd be easy, I don't know whether it's easier to draw the, maybe it is. What have we got? U, C, I think these are countries, I seem to remember.
Okay.
And I think, no, not countries, languages. And it was translations. It was how much it cost to translate from that language to the other language.
Okay.
So, for example, say it costs, see English to French at the top is 175 and French to Russian is 85.
Yeah.
If you translate the English into Greek, or German, I think that one was, if you translate the English into German and then the German into Russian, then you get from English to Russian, but cheaper than if you go by French.
Yeah.
Yeah? So that's the idea. So start where you like.
So I'll start from
pick your vertex.
Greek.
Okay.
Okay.
So you're going to bring in a language as cheaply as possible into your existing tree being Greece.
So French is the cheapest, because that's 25.
Yeah.
So can I draw little further dots?
Yes.
Right, so I'll do that.
Yeah.
So that's GR to F, and that's 25.
Perfect.
And then, hang on, I've got to like assess where I am.
Yeah, so if you look at your tree, rather than looking at the whole messy graph, if you look at your tree, you've got to connect something to French or something to Greek.
Yes. So if I want Russian in there, I've got either 52, 85 or 85, so I'll go for 52.
So why are you bringing in Russian?
Because I have to connect that node. I don't need to connect it to GR.
You need to bring anything at all into the existing tree as cheaply as possible.
Right. So if I went for... So if I go for G...
So it's almost like you're a language company.
Yeah.
And at the moment you've only got people who translate French and Greek, and you want to introduce a new language into your translation firm. Which language are you going to bring in? There's no point bringing in something where the French and the Greek people can't translate.
So
it's got to connect.
German.
German. That would be, how much would that cost to bring that in?
So 42 or 55 from France.
Wouldn't it be better to bring in the Chinese? Because that's only 35 into the...
Right.
Yeah.
I see what you're doing. Okay. So Chinese.
Yeah. Because then that's only 35.
GR to C.
Yeah.
Okay. And then...
So at the moment, we've got, this is in our tree, and this is in our tree. What else have we got? That's it, isn't it?
That's it, yeah.
So what can you bring in now, cheap as possible?
I see. So
the smallest is 25, yeah? From whatever that is, Icelandic to Greek, 25. Yeah. But we can't bring that in.
Because we haven't connected.
No, because we need to come into our existing tree.
So the cheapest next alternative is 42, so to Germany from Greek.
What about Icelandic to Greek?
I haven't. Oh, Icelandic to Greek. Oh, I didn't see the 38. Thank you. Didn't see that. Icelandic to Greek.
Yeah.
Right. Okay. Right.
Yeah.
And
so
then
that's this
I
one.
can connect to.
Yeah. So Greek is now in, Icelandic is now in, Chinese is now in, and French is now in.
Okay.
But we've still got Urdu, German, English, Russian.
Right. So connect German. So that's 25.
Yeah. Yeah. So German's now in.
Yeah.
Yeah, but we've still got Russian, English, Urdu.
So from Urdu, it's 68.
Yeah, there's nothing. Is there a way of bringing English in cheaper than that?
It's 93. No. Look at that. From Greek to English is this huge one.
Yeah.
So do I have to draw it around like that?
Yeah, there's a sneaky one.
That was sneaky.
Yeah, so the English is now in.
Yes.
So this is now in, via this. So we've only got Russian and Urdu, so how cheaply can we get either of those into our existing tree?
So it's much better to take... It's probably better to go 52.
Yeah, bring
Greek.
the Russian in. The Russian...
Yeah. From Greece.
Yeah.
Okay, so Greek to Russian. 52.
Yeah, that's it.
And then finally, what did you call that one with you?
Urdu, I think it was.
Urdu. So take that, I suppose, from you. That one has, this one we got back.
That is a good point. That is a good point.
So for that one,
let's assume it's massive and that 68 is the...
Okay.
Yeah.
So U to C is 68.
Yep, that's it. And now they're all in. So there was no need to check for cycles because each time we brought in a node that wasn't in the existing tree. But you can see, compared to this one that we did, it was really obvious which one to bring in next. Once you've got loads and loads of arcs all over the place, it is actually quite
difficult. That was not obvious.
No, it's not obvious. So in that sense, Cryscal's better because it's so systematic. You list them all smallest to biggest, add, reject if it makes a cycle. It's obvious it makes a cycle. No thinking really.
Yeah.
So this in a sense is harder. So yeah, back to the sort of similarities and differences. Prim, next video can be applied to a matrix, which Cryscal can't. Prim can start anywhere. Cryscal has to start with the smallest. That's a restriction you don't have on the Prim. Prim is bringing in a node at a time. into an existing tree. So there's no need to check for cycles, and you always have a tree. You just need it to be a spanning tree. Crystal is bringing in an arc at a time. You do need to check for cycles, and your trees might pop up all over the graph as subgraphs, and then they come together at the end into a connected overall spanning tree. So, a couple for you to try that are in your pack. I think it says in your pack where to start. So start there and have a go at doing Prim yourself. Just give you 5 seconds, pause the video, and then have a look at the answers. So this is the answers to both of them, and the important thing here is the order. This is what's important. Not so much the tree itself or the total weight, although obviously they should be correct, but the order in which you added the arcs. That's how you're going to be examined on this, is that order. So you must remember to keep writing them down as you collect them. Ready to apply it to a matrix?